EBSCOR, the experimental program to stimulate competitive research, is a National Science Foundation grant program. The goal of EBSCOR is to strengthen science and engineering research and education throughout the United States, and to enable states like Wyoming to be nationally competitive in these areas. EBSCOR aims to improve scientific infrastructure in Wyoming and build science, technology, engineering, and math research capacity across the state. One way Wyoming EBSCOR helps strengthen science research and education is through student programs such as the Summer Research Apprentice Program, also known as SRAP. SRAP is an intensive 6-week paid research experience for high school sophomores, juniors, and seniors aiming to attend college. It offers students a hands-on research opportunity in science labs across the University of Wyoming campus. Students work one-on-one with a faculty mentor throughout their time in the program. SRAP not only provides students with a paid internship and real research experience, but also helps prepare them for college life.
Griffin Gilmore from Woodland Hills, California, and he will be presenting Isotope of Laramie River and Crow Creek tributaries.
Good morning. My name is Griffin Gilmore, and my project was to create Isotope of the Laramie River and the Crow Creek tributaries. This presentation consists of a short introduction, followed by methods and results, including the isotopes, and then finishing with a discussion. Hydrology. Hydrology is the study of water and how it moves throughout the earth. Isotopes is a map that hydrologists use to understand how water flows. This right here is an example of an isotope. An isotope shows ratios throughout an area. This is an isotope of the United States, with the blue showing the areas with lighter isotopic ratios, and the red showing heavier isotopic ratios. Isotopic ratios are read in an isotopic value. 0 representing the isotopic ratio of the ocean, and anything less than 0 means it's lighter than the ocean. In the water cycle, lighter isotopes evaporate first. As clouds move inland, the heavier isotopes precipitate first. This means the cloud becomes isotopically lighter as it moves throughout inland. When evaporation occurs in a body of water, lighter isotopes evaporate first, meaning the body of water gradually becomes heavier. The objective of this project was to create 2 isotopes, one of the Laramie River and another one of the Crow Creek tributaries. The methods had 3 different phases: the collection phase, the laboratory phase, and the construction of the isotope. For the collection phase, we first used Google Maps to choose points along the Laramie River and the Crow Creek tributaries where we would collect our samples. After driving to each site, we would collect the sample in a small 20 milliliter bottle, then record the coordinates on a GPS and mark location on the GPS. Then we would record the time and date and finish by taking a picture of the area where we collected our samples from. Then the laboratory work came. In the laboratory, we first took our samples and prepared them for the liquid isotope analyzer. First, the samples were transferred from 20 milliliter bottles to the microliter bottles. These bottles had a special cap that allowed the syringe and the analytics PAL sample handler to pierce the cap and take a small sample of the water. After loading into the sample handler made by Elite Technologies, the water was then transferred to the liquid water isotope analyzer by Los Gatos Research. The liquid water isotope analyzer is a special machine that first turns the sample into a gas. Then the gas is ionized, so that has a +1 charge. Gas is then shot through a flight tube that's bent. At the bend, there's a magnet that separates the particles. The heavier particles bend more at the bend, bend less at the bend, while the lighter particles bend more. At the end of the flight tube, collection cups collect and count the particles. Then we receive in our data logs the isotopic ratios in values for each sample. The machine does this 6 times per sample and takes about an hour to run. However, we only use the last 3 readings for accuracy purposes. Finally, there's the construction of the isoscape. Coordinates are first taken from the isoscapes and are loaded into Garmin Basecamp. Garmin Basecamp is a software that works in conjunction with the GPS. From Garmin Basecamp, the coordinates are transferred to ArcGIS software. ArcGIS software is used by many geologists to construct maps and understand geography within a location. Using ArcGIS maps, we were able to finally construct the isoscapes. This is the Laramie River isoscape we constructed, and this is the Crow Creek tributaries isoscape. In the isoscape, we first took we represented the lighter isotopic ratios with green, and with red representing heavier isotopic ratios. In the results, we noticed 2 different things within the Laramie River. The higher elevation portion of the Laramie River had a much slower rate of evaporation. At the lower elevation, we noticed a much higher rate. This was because at the higher elevation, there's more tree covers and a faster flow rate, along with colder temperatures. While the low elevation portion was in the prairie, meaning it had a lack of wind cover due to there being less trees, warmer elevations, and slower flow speed due to the flat topography of the prairie. For Crow Creek, however, even though the elevation of Crow Creek was similar to the higher elevation portion of the Laramie River, it had a faster enrichment rate. This was due to the fact that the Crow Creeks had beaver dams slowing down the water and also diminishing the tree blockage from the wind. Major impacts on this project was the beaver ponds within the Crow Creeks. The beaver ponds dramatically impacted the enrichment rate in the Crow Creek tributaries. By slowing down the water had more time to evaporate and enrich before bridges or towns. A possible improvements that could have been made to this project was that we had included the Little Laramie River in our isoscape. Another improvement we could have had was having more samples from the Big Laramie River. In the Laramie River isoscape, there's a large gap right here. This gap is also the transition from the higher elevations to the lower elevations, which was an important part of our project. If we had more samples along this area, we could have understood better how the transition occurs. I would like to acknowledge my mentor, Dr. Scott Miller, for the help he gave me throughout the project, along with his graduate students, Alan, Tony, and Jara. I would also like to thank the University of Wyoming Stable Isotope Facility Manager, Craig Cook, and of course, EPSCoR and the SRAP staff. I would also like to thank my parents, Grant and Carrie Gilmore, for their help, their support throughout this project. Any questions? Yes?
I'm curious. Your research, like a lot of the other research, is ultimately funded by taxpayers. So what is the end result for us as taxpayers of your research? What do we benefit?
Well, the Laramie River and the Crow Creek tributaries feed into the Colorado River, which is a large source of water. A large source of water for many, many people. By understanding how water flows through this area, we can understand what the quality of water is by the time it hits that Colorado River, which can impact our drinking water. Anything else?
So you said you use Google Maps to find the sites where you collect your data.
Mm-hmm.
What were so significant about the sites you picked just off of Google Maps?
The Google Maps, one, we picked the sources of the rivers and all the streams in the Crow Creek tributaries. Also, we use Google Maps to find what roads would we use to access the river, along with points every so miles so our samples are accurate. Yes?
Did you measure the isotopic ratio of the stream flowing into a beaver pond and then the outflow of the pond to look at the processing within the pond?
We did it for a couple, but since in Crow Creek there are a lot of beaver ponds, and we only had so much time, so we got a few, but not every single beaver pond we were able to do a before and after for.
And what'd you find?
We found that since beaver ponds are usually in sequence, there's not just one beaver pond per stream. So when we did it closer to the source, we noticed that the beaver ponds had a huge impact since they slowed down the flow of the water, therefore giving it more time to evaporate and also exposing more wind to sweep across the water and cause more evaporation. Anything else? Yes?
You also mentioned
Enrichment,
enrichment.
enrichment is another way of saying evaporation. When evaporation occurs, the isotopic ratio of the water becomes heavier and heavier because O16, the ratios is O16 versus O18. When evaporation occurs, O16 leaves first, leaving more O18 behind, making it heavier. When enrichment process is that evaporation process. And when the water becomes more enriched, it means that isotopic ratio is becoming heavier and heavier. Yes?
And I'm sorry, so then what is the impact of it becoming heavier?
I'm sorry.
So you said it becomes heavier when it becomes 018. Then what does that mean? What is the impact of that?
Well, we understand when something becomes more enriched, that means we know more water is being evaporated. When we know more water is being evaporated, we know where the water is going. If I understand how water flows throughout an area, we understand how it can impact other streams and rivers that it feeds into. Anything else?